Okay, so in the previous video, we addressed question 5M1 for Statistical Rethinking, second edition. And now we're addressing question 5M2. They're wrapped together in the Colab sheet, but I'm putting them in separate videos. So go back and check 5M1 if you haven't already. These two questions are somewhat related. In the previous video, and for 5M1, we looked at spurious correlations, and we drew a DAG for the spurious correlations, and then demonstrated by generating data that we made and then running regression on that data. We saw the consequences of including this F variable, this fork variable that creates spurious correlations. In this video, we are instead looking at masked relationships, which is the other kind of motif that's described in the chapter. Let's get into that. So the first thing I'll do is describe a masked relationship. We'll build a DAG representing the masked relationship, and there's two ways that we can do it. We'll come back and do it here in R. But again, you can also, if you don't want to code it, there's a lot of amazing functionality in this website called daggity.net. I'm sorry, I don't have the browser address in frame here, but it's daggity.net, D-A-G-I-T-T-Y, and there's a link in the question. So if I go to launch, I'm immediately brought to this page here. And this is where my DAG is going to go, and it just shows an exemplary DAG. So I need to delete all of these. There might be a faster way to do this, but let's delete all these. Oh, I actually want to delete you. Okay. So if I want to make a DAG, it is as simple as, first I'm going to click somewhere on the screen, and I'm going to label it. So I'm going to label this first one X. Okay. This next step you don't necessarily have to do, but I am going to. So X I'm going to call the exposure, okay, and then I'm going to create another one, and here I'm going to call it M. And when we're talking about spurious relationships, M stands for mediator, and this pattern that you're going to see here is sometimes called the mediator, or the pipe, I believe that McLareth calls it. Okay, and then I'm going to put Y as the outcome variable. Okay, and I'll call Y an outcome. And so to create my pipe or my mediator motif, I just click on X to Y and then M to Y. Okay, and so then this is what my mediator motif looks like, and this is the thing that causes a masked relationship, right? So we're saying that X affects Y through M. And what we'll see is that when I include M in my regression, in my analysis, the relationship between X and Y is masked because X is working through M. Okay, so now you can copy and paste this code into R, although you need to do a few things to it to make it, so you'll see it on the other screen, but to make it run in R, you have to do a couple of things to it. But so let's go back. Okay, so let's build that DAG here in R. So you need the library Daggity. So make sure that's installed and uploaded on your in your R. Okay, and so I'm going to create a DAG, a picture like we just saw, and I'm going to call it masked or msk-rel DAG. Okay, so I use this command here, and you'll see I have X, M, Y divided by these arrows, right? And then I'm just going to lay out some coordinates for the X, M, and Y, X and Y coordinates. Okay? And then I'll draw the DAG here. Okay? I should also say, like I do at the top of every video, but have forgotten here, make sure that you have installed and loaded the Rethinking package with these two bits of code here. Okay, but anyway, where are we at? Okay. So here is my DAG, right? So I have X is affecting M, and M is going on to affect Y. Okay? And like I said, in a masked relationship, X does affect Y, but it works through some mediator variable, right? And so for example, we might think of this as maybe Y is blood pressure, and X is a medication that reduces blood pressure. and M is the mechanism by which X, the drug, affects Y, blood pressure. And so here, let's say that it is blood volume, or let's say that it's urinary output, and that's going to affect blood volume, right? So the more that you urinate, the less blood volume you have, and your blood pressure tends to drop. And we're just going to say that's how this drug works. Okay. So we're going to run some code here where we're going to simulate an experiment. We're going to simulate some data where we have different doses of the drug given to people, and that drug is going to affect their urinary output, and that is in turn going to affect blood pressure. Okay, so let's look at some of that code. So we have X here, and X I'm just calling a log normal variable, right? So I just have a bunch of positive values for the drug dose. Okay, and when you run this in code, you'll just see a bunch of numbers greater than 0. Okay, and that's the drug dose. And now I have M here, and I'm saying that there is maybe a normal output of 120 units of urine being produced every day, and that is being affected by X. Okay, so whatever the dose of the drug is, it's on average, changing urinary volume by 10, and then some random noise here. Okay, and so this M here represents urinary output of the drug, and then Y is a function of M, right? So I have M minus some noise, right? So M again is blood pressure, M is urinary output. Okay. So first I'm going to run the regression where I include both X and M. Okay. And here I apologize again, I'm not using the Rethinking or Bayesian format here. I'm just using a frequentist command, the LM command in R, but that's fine. It will demonstrate the point here, and that'll be good. Okay, and what we're going to see here is that even though we know that X is affecting Y, that the drug is affecting blood pressure, by including M in our regression, the effect of X is going to be masked. Okay, and then I'm going to run a second regression in which I do not have M in the regression. I just have X. And now the effect of X will be revealed. And so let's run this. Okay. If this output looks a little bit daunting, we'll go through it. So there's two chunks here. Here's a chunk, and then here's a similar chunk here. And this first chunk corresponds to the first regression. Okay. And so you actually see right here the formula that was used. That's the first regression. Okay. And we're going to skip down here to the coefficients. So here's the coefficient for X, drug dose, and then the coefficient for M, which is urinary output. Okay, and we see that the effect of the drug has a very weak relationship by virtue of the p-value here, right? So it's a very high p-value, meaning that whatever effect the model is extrapolating about X, it's very weak. But we do see that M is very powerfully associated with blood pressure here. Okay, it's a highly significant finding. Okay, but again, we could be misled because even though in this situation, it's obvious that this is an inappropriate DAG because we made the data. We're telling the story. But if you're looking at the world, if you're looking at nature, that might not be so obvious. So anyway, so now we'll go on and look at the fixed, what I'm calling the fixed regression, where we omit M, and that is here. Okay, and now we see that the effect of X on Y, or I should better say the association of X with Y, but based on our knowledge, we're saying that X causes Y. Now we have a highly significant finding. Okay, so that is exactly as we expected, right? When we don't have the mediator masking the relationship between X and Y, we find the effect of X on Y. Okay, so now hopefully you've watched both videos for 5M1 and 5M2, and there's something important here. Okay, so for both the fork structure, okay, in the spurious relationship, as well as the mediator or the pipe structure for masked relationships, when we when we include m in the regression, or we could say that differently, when we condition on the middle variable here, f or m, we disassociate, according to the regression, we disassociate x and y, okay? But in one regression, that's desirable. So in the fork, it's desirable that we disassociate x and y if we're worried about possible effects of x on y. It's desirable because based on our previous knowledge or our conjecture about the system that we're looking at, x doesn't affect y. It's only, the relationship between them is spurious because they're both affected by f. And so it's desirable to put f in the regression. However, in the second regression, including the middle variable here, is probably undesirable. There's questions where it would be desirable, but if we're just worried about the effect of the drug on the outcome, on blood pressure, including the middle variable is undesirable. And so whether or not we're including these variables in the regression is very much dependent on our knowledge about the system, conjecture about the system, hypotheses about the system. So anyway, I guess that is it for this one.